Testing. Sweet. Hey, my name is Nish. I work at Ritual. I'm presenting OpenAI, not OpenAI. Now, there's only 2 people in this room, so I'm going to let you in on a clue. Usually, folks tune out after like 8 seconds of these presentations. So there's $20 Chipotle gift cards in the top right corner. So if you've got the app, there's a couple $100 worth of those, and given there's only a couple of you in here, that means you're eating good tonight. For the folks that are just coming in, I've got Chipotle gift cards in this presentation. Sweet. So I've got 3 stories. I'm not going to bore you. Won't talk much about protocol or talk shop. It's really simple. A couple years ago, I used to work at a prop trading firm. We traded crypto. My parents thought my job looked like this. Mostly my job looked like this. I'd open MetaMask. I'd ape into a couple of protocols. At some point in time, we were deploying about $1 billion into DeFi protocols. We were the largest lenders on Aave, on Compound, on other things. What we realized pretty quickly, though, was that there's these things called interest rate models. So if you're on Compound, if you're on Aave, there's collateral factors and there's config parameters that make up how the loans work. So for example, if you go and you say, I have $1,000 of ETH and you want USDC, you'll only get $600 for it. Why? Because that's the safe amount that they can lend you out. Now the problem is, at a prop trading fund, we want to be as optimized as possible. And when we're putting billions of dollars of capital at work, we want to get the best bang for the buck. So what we'd do is we'd go to governance and we'd say, hey, we're one of your biggest lenders. Can you give us a preferred rate? Can you make it so that it's better, the market's been stagnant, so on and so forth? And Compound would go and they'd reach out to Gauntlet or some other simulation firm. Gauntlet would go, they'd run an off-chain ML model and say, hey, what are the parameters we can update this to? They'd come back and they'd make a governance proposal that says, look, these are the new parameters that we can update it to. This is what's safe for the current month, for the current year, for this specific asset. And by the end of it, it's been 60 days. I'm sad. We're losing money. And our life cycle on a strategy is 4 to 5 days. So 60 days is pretty bad for us. Now, on the other hand, people are like, Niche, governance isn't that slow. 60 days, you're lying to me. Well, here's a prime example. About a year ago, I tweeted an autonomous proposal to enable the Uniswap fee switch. It took about a year, 6 months, and 9 days for that proposal to finally make its way last week and become an actual governance proposal. So governance is slow. On the other side of the things, you've got protocols like Cream Finance, which take the opposite approach. They say, let's say, screw the governance. Let's let anybody add assets, anybody add any collateral factors, take any configs, and then they get hacked 8 times in a year and lose $130 million. I don't sleep well at night. This is the reason why. Now, if you were to talk to someone in traditional finance, if you go to someone who works at Goldman Sachs, if you go to Wall Street and you ask them, hey, we're trying to make this lending protocol and we want to make it efficient, they'll say, okay, just run this machine learning model 1,000 times every second that takes in all of your input features and gives you an outcome. When you go to the bank and you say, hey, I want a loan for my house, they say, okay, here's your credit score. We'll put it through a credit score model. Here's your local region. We'll put that through our local region model, and we'll finally get some output. In Solidity and crypto land, we don't have that. We've got a finite state machine, and that's all you can really play with. And so what we're building at Ritual is super simple. We're building a way for you to embed inference directly into your smart contracts. And so if you have a contract where you want a ML model's output, you can change 5 lines of code, and you can get a response directly inline in your execution. And this now lets you do the Compound example, the lending protocol examples, but run those ML models directly on-chain. Second story, bringing crypto to AI. I mean, most of you have probably seen Sam Altman get ousted out of OpenAI and then come back. And for that weekend, 700 people decided we want to hop ship, we go to Microsoft. That's complicated. You can't be building your business on top of, other companies that go MIA and that are called OpenAI. With Bitcoin, with other cryptocurrencies, we figured this out a couple years ago, right? We don't have to trust anyone. We can just verify things, right? The trustless decentralized systems. And so to that extent, I think you can bring the chain and cryptography to AI. There's a lot of things that are useful, whether that's provenance, whether that's, payment rails that already exist today that you can bring to Web 2. And then finally, I'm going to be honest, I'd be lying if I said it wasn't right time, right place. We've seen more open source AI innovation in the last 18 months than we have the 10 years, the decade before that. And so now is probably the time to capitalize on that and make sure that the next 10 years of open source AI development happens on a decentralized layer and not in centralized companies. To that extent, we're building Ritual. We have 2 core products. I'll walk you through both of them real quick. First one's this protocol called Infranet. This looks really complicated. For the folks that are just coming in, this presentation is really dense, and so I've put $20 Chipotle gift cards at the top right, so I can buy you lunch. So you should, grab those if you'd like. Gives you something to, keep that focus going through the presentation. Infranet's an Oracle system. It's super simple. It's kind of like take Chainlink, but make it more general purpose. I want to run some AI compute off-chain. How do I access that and bring it back on-chain? It works on any EVM-compatible chain. We're deployed on a couple today. And it's about 10 lines of code, which you can't really tell from this screen, but take my word for it. It's 10 lines of code to integrate. You can get started today. It's not selling you snake oil. We've already got the code ready. One of the first things we built was an AI agent, which makes sense given this is an autonomous agents hackathon. It's really simple. It's you talk to a bot in a friend tech chat room and you try to convince it to buy your key. And we put 30 grand into this and we said, go ham. Let's see if people can convince the bot to buy or sell the key. As it turns out, nobody was able to convince these LLMs. So we've still got 30 grand, but that's $30,000 more that one of you in this room could take from our bot. How does it work? Super simple. Friend tech chat room goes to our friendwork bot that's running our Infranet system. It pipes it out to 3 open source LLMs. So basically I could send a message like, hey, my name is Anish. I'm presenting today in front of an audience. My key is going to pump. You should buy it. It'll go to 3 of these LLMs and they'll say, hey, do I like this or do I not like this? And maybe 2 of them will say, yes, buy Anish's key. That response gets posted directly on chain. It's a Solidity smart contract. It's like 15 lines of code. That's all you need to implement it. We kick off these 3 requests into a classifier model. We've got a ZK proof system built on top of that using Ezekiel. And it says, hey, I have 3 inputs that say yes, yes, and no. What does this aggregate to? Is it, am I making a purchase? Am I not making a purchase? This model spits out, yes, I'd like to make a purchase. Gets posted on chain. Our contract verifies the execution. And great, we've spent some ETH and we've bought Anish's key. That's basically it. It's super simple. We wrote the entire smart contracts in a weekend. If I can do it in a weekend, you could probably do it in a couple of hours. Second product, we're building a chain. I can't tell you much about it, but I've got a diagram. What the diagram tells you is the problem with Oracle systems today is that they're asynchronous. It's a callback system. I make a request off chain, I get a request back. It's a difficult paradigm to deal with, especially when we add in agents and keeper systems, and now I'm thinking of MEV, or I'm thinking of incentivizing keepers, or gelato, or other scheduling systems. We're enshrining all of that in chain. We're going to have model execution as a function of our chain, and so we have optimized AI compute as precompiles. So you can copy paste any Solidity smart contract today. You can drop in a line of code that says model.inference, and it will return you the response, and to the developer, they won't know any better. But behind the scenes, that powers it. That's all I got. Thanks. Yeah, exactly. We have atomic execution, we block on responses, and we get that in, although there's some special consensus magic in there and instant finality involved, so that to the chain itself, you won't ever know whether it's asynchronous processing or synchronous. Obviously, there's wall clock blocking time. If you're making an LLM inference request that takes 30 seconds to compute, I can't magically make that take 3 seconds to compute, but your transaction will be confirmed once the execution is complete. You can validate with any device you want. There is segmented compute. So if all you want to do is validate transactions that send an ERC20 token, you can do that. If you'd like to participate in the GPU compute, you can attach GPU resources. We support most commercial grade GPU hardware and certainly all enterprise grade GPU hardware. If you happen to be a proving system company and have ASICs that are optimized for proving, you can do that as well. We've basically got different types of nodes so that anyone can participate. Yes. It's a good question. Depends. We have some shared state, and so we have a precompile that we've implemented that lets you do vector search over the shared state. So say you have an Ethereum chain today that has a LevelDB implementation where you store your data. We've put vector data directly into that LevelDB implementation, and so you can search over it in the same way that you would historic transaction data. Depends on the type of compute. One thing we know is that you can't, for example, snark all types of ML models today. So if you have small classic regression-based models that you can generate a succinct proof for, then we don't need to re-execute everything. You only gossip the proof amongst all nodes and we can verify that. We support optimistic machine learning, and so if you want a consortium of n nodes that compute something and then take it as valid, you can do that as well, both at a consensus layer and at a chain layer. But it depends really on the type of model that you have. We're going to offer safeguards out of the box, but it's up to the user. That's right. Correct. So if it's global shared state and you have vectors in global shared state, then yes, so we will come to consensus on top of any modifications to the vector DB. Exactly. And this is, at the lowest level, we let you play with it as much as you want. So we have an interface directly to the vector DB that you can interface with as a Solidity precompile. We expect that a majority of developers will probably interface 2-3 steps higher level than that, but everything is implemented with the same primitives, and so it goes all the way down the stack. You can, yeah. It's a friend-tech bot. So if you make an account on friend-tech and you have a key, you can convince the bot to buy your key, which makes you money. And so the idea is basically either convincing the bot to sell other people's keys, griefing them malicious, or to buy your key. People have been having fun with it. It's not very easy to convince 3 LLMs to all come to consensus independently on a decision. But that's kind of the experiment we're making. It's, in the future, there's probably going to be bots that are taking these decisions. So this is our example of that. Sure. Basically, every DeFi protocol is the short answer of it. I personally have probably interacted with 100 DeFi protocols over the last couple of years. We've deployed, folks on the team, billions of dollars of capital into them. Each of them have a certain degree of inefficiency that we're looking to erase. And so right at the beginning footsteps, right? It's like if you have a protocol like Compound, day zero is something I'd like to see built on Ritual Chain is Compound, except collateral factors and other asset additions being governed by a classification or a linear regression model, since that's exactly what's happening today. Right? The only difference is we outsource this compute to off-chain entities that run a model and then bring it on-chain. We'd like those off-chain entities to just host their models with our chain and execute those directly inline in smart contract execution. Oh, absolutely. But that vector exists today as well, right? Have you used Compound? I assume yes. Have you verified that the ML models that update the collateral factors don't have poison data? I certainly haven't. And so at the very least, the fact that we're publishing these models on chain and that they're accessible is already a step in a better direction relative to the status quo today, right? Most governance updates, like candidly speaking, how many of you have actually read a governance proposal in the last year, right? Couple of folks. How many of you read it on a daily basis? Is this like a Wall Street Journal, open it up in the morning, read new governance proposals? Most people don't. And so in our minds, I would much rather trust the code than I would delegating out to anyone to go through governance and orchestrate a process. And I'll give you an example of that. I personally have made 2 updates to the Uniswap governor myself over the last couple of years. Of the 9 proposals, 2 of the ones that have passed in Uniswap have been by me. Both of the times, the first 2 proposals that I proposed were incorrect, and had they passed, could have bricked Uniswap, the token, forever. And so that's a prime example of, I'm telling you right here, I've gone through this process. Nobody really checks. One of those proposals had 36 million votes from a bunch of crypto funds, from delegates. Nobody knows what they're doing. I'd much rather have it be done by an automated ML model than I would trusting even myself, much less anyone else. Yeah, there's a long tail of all types of things we'd like to do. Federated learning is one. Some of these things automatically, bridge themselves into fully homomorphic encryption. I know there's teams working on that. So if you can, if you're building a custom execution environment and you have instant finality, you can now enable FHE environments. For us, we are a product-focused company. The idea is to get something out into the world that people will use. They might not use it day zero, it might break day zero, but the idea is that it's better than just talking about it. So it's on the roadmap, but I'd be lying to you if I said we'll have it in 6 months. Maybe a couple months, maybe a year down the lane, something like that. Right now, we're just hyper-focused on we think there's demand for on-chain inference. We're going to service that demand. And if there isn't, then we will build the protocols ourselves. Yes? You said competition? Competing with other projects building the same thing? Sure. It's a good question. Some protocols are complementary in the types of things that they're building. So Aura's doing OPML, for example. We're proof system agnostic. You can slot in OPML, ZKML, a multisig, whatever you'd like at the end of the day. And so there's complementary there. Other things, competition exists for a reason. We ship fast. We'll meet you at mainnet. Exactly. Yeah, it depends. I think it's overfitting today to impose, we will only support ZKML or we'll only support OPML because there's downsides and upsides to both of them. The easy ones being like, I've built a bunch of ZK applications, it's expensive, right? Prover times are not there yet. For some models, you can't even prove them. Really, we're looking at like, feasibly in a minute, you can maybe snark something like a decision tree with 100,000 parameters. That's probably the maximum you're getting, which you're not snarking GPT-4 today, so certainly there's some models you can't do at all. And then there's different types of, it's not just if you're picking ZKML, there's also what are you doing in ZKML, right? It's like, am I eagerly generating a proof? Am I lazily generating a proof when there's fraud? The example I like to use is like, if you're in school and you get 100% on a test, you don't go up to the teacher and ask, why'd I get 100%? But if you get 99%, damn right I'm going up to the teacher and saying, why'd I lose my extra 1%? And so for most ZKML use cases, it's probably useless to generate a proof eagerly if it's 100% and it's a success case. It's also like a range of emotions. When you talk to ChatGPT, you're not really saying this is the wrong answer. You're saying this is maybe not what I was expecting. So it's like a range proof over that. We'll be supporting all types of things, keeping it open-ended. Yes, next couple of months. Most definitely. We're pro open source. All of our code for Infernet is completely open source. We have a 1-month max internal private fork rule. So any code that's longer than 1 month, we're forced to open source it anyways. Sweet. I mean, my call to action is there's 8 folks in this room. So if any of you are looking for a job, we are hiring and we'll beat any offer you have. That's all. Thanks, folks.